Hi, today we're going to talk about how can you tell if a graph, table, or equation are proportional or do represent a proportional situation. So let's start with a graph. So to determine if a graph is or is not proportional or does not represent a proportional situation, it has to meet two requirements. The first is that it has to be linear. That means it's a straight line. Whether it's up, down, sideways, whatever, it has to be a straight line. Okay, and then the second is that it has to go through the origin, which is 0, 0. So for example, if I have my coordinate plane, I'm not drawing it great, but that's all right. And I have something like this. Well, that is a straight line, but it does not go through the origin, so this one is not proportional. But if I have something like this, and I'm going to have to draw this a little more carefully, it is a straight line and it does go through the origin, so yes, it is proportional. Okay, I could do another example with a negative, a line that's going down. Something like this goes through the origin and it's a straight line, so yes, it is proportional. So that's for a graph. The next one I'm going to look at is an equation. For an equation, yes, the equation is proportional if it follows this form y equals kx. Now, those letters don't have to be exactly the same. You can use whatever letters you want, but the form is that you have a letter that equals k, where k is actually called the constant of proportionality, and we're going to talk about that more in another video. But so k is some number times another letter. So for example, I could have the equation y equals 3x. Yes, that's proportional. Y equals negative 2x. Yes, that's proportional. Y equals 4x plus 1. No, that's not proportional because it had this plus 1 that we don't want. How about y equals 2x minus 3? No go, it's not proportional. It has to follow this kind of format. It could be a fraction. That's okay, like y equals 1/2 x. Totally fine. Yep. So that's graphs. It has to follow this y equals kx, where k is the constant of proportionality. Did I say that's graphs? I mean, that's equations. Our last one is tables. Tables take more work than some of the other ones do. So I'm just going to show you some basic examples. If I have a XY table like this, or a T table like this, then one strategy, honestly, there's a few different strategies for deciding if yes or no something is proportional or not. But I'll just show you this one. This is my favorite, and that is to take each coordinate point and divide the y value divided by the x value. And if you always get the same thing, then yes, the table is proportional. So I'm just going to go ahead and do 1, 2, 3, 5, 7. And it doesn't matter if they're in order or not. What matters is what's happening over here. So let's call this 3, 6, 9, 15, 21. And we're going to divide the y value divided by the x value. So for this first one, we do 3 divided by 1, which that's just 3. That's pretty easy. And for the next one, again, it has to be y divided by x. Yeah, it has to be in the same order every single time. If you change it up and do x divided by y and then sometimes y divided by x, that's going to totally throw it off. So please make sure you always do y on top divided by x on the bottom. So far, so good. So far, we've always gotten the same number 3, but we can't just stop here and say we're golden, because what if suddenly it changes? So we got to keep on checking. And we just do the y value divided by the x value, which in this case is still 3. And the y value divided by the x value, and we learn that, hey, yes, this is proportional. And 3 is the constant of proportionality, which I mentioned in the equation. And again, I will teach you about in a different video. So this one's a happy table. Let's go ahead and take a look at a different one. I don't know, I'm just making it really big, I guess. That's a weird one looking table. That's okay though. And again, it doesn't matter what the numbers look like, 4, 5, and 10, right? Doesn't matter if they're in order or not. What matters is when we divide, am I going to get what I'm looking for? So, and I did 0, but I don't want to do 0 because 0 is kind of a special case. You can't divide by 0. We'll do -1. How does that sound? Okay. So it's going to be -3, 7, 9, 11, 21. And we're going to divide y divided by x. So -3 divided by -1. Well, hey, that's 3, just like the other ones so far. That's pretty cool. And then we do 7 divided by 3. Oh, excuse me. 7 divided by 3, and suddenly our hopes and dreams are foiled because 7 divided by 3 is actually 2 1/3. And we don't even have to keep going. We can stop because already we've gotten 2 different numbers. So no, it's not proportional. Okay, so we've done a graph, a table, an equation. Just as a reminder, a graph has to be a straight line going through the origin, 0, 0. An equation has to follow the form y equals kx, where it's some letter equals a number times another letter. And a table, you have to find y divided by x for each point. If it always equals the same number, then yes, it's proportional. If you get different numbers, then no, it is not proportional.